Hey, what's going on, guys? Let's look at this problem right here. Here this question is asking which of the following signals is or are periodic. Now let's check the options one by one. Let's go for A. Option A says S of t is equal to cos 2t plus cos 3t plus cos 5t, and we know that period is equal to 2 phi over omega. 2 phi over omega. And if you look at the first one, cos 2t, t1, let's say this is t1, 2 phi over, and omega, this is actually cos omega t. Omega is 2, so 2 phi over 2, that's going to give us phi. So this is our t1. Now let's go ahead and check t2. T2 is going to be what? We are going to have 2 phi divided by omega, that's 3, so 2 phi over 3. And if we check t3, that's going to be what? 2 phi divided by omega is 5, so we have to divide just this one by 5. So this is our t1, t2 and t3. Now we have this one, and we have to divide each of this and see whether we are getting a rational number as ratio. If we get a rational number, it means that is periodic. Now let's go ahead and see that. So t1 divided by t2, that's going to be equal to what? T1 is phi and t2 is 2 phi divided by 3. 2 phi divided by 3. And from this one you can see this is 3 by 2. This is a rational number. Rational number. And also if you look at this one, let's look at t1 divided by t3. T1 is what? Phi divided by 2 phi divided by 5, and that's giving us 5 divided by 2, a rational number. Rational number. And let's look at the next one, t2 divided by t3. T2 divided by t3, that's going to be 2 phi divided by 3 divided by 2 phi divided by 5. 2 phi cancels, 5 will flip around, we will get 5 divided by 3, and this is also a rational number. Rational number. So here we have these three, and this is periodic because we are getting rational numbers, so periodic. So this is periodic, so this is the answer. So A is periodic. Now let's look at the B part. Okay, let's get rid of this one. So let's look at the B part. B part is, actually B option is S of t is equal to exponential j85 t. So exponential mean e power j85 t. Now here what we are going to do is we are going to write this one as another function, like S of t is equal to S of t plus t. Let's call this t. This is our period. And let's put 2 phi for this one. Period is equal to 2 phi. Okay, now what we are going to do, we are going to see what we are going to get for S of t plus 2 phi. S of t plus 2 phi. That's going to be what? E power j85. Instead of t, we plug t plus 2 phi. So this is what we are going to have right here. Here we are going to use Euler's identity to expand this one. Euler's identity says this one can be expanded as cos 8 phi t plus 2 phi plus I, like or I or j. If you are engineering, this is j because I is used for current, so we use j for this imaginary part. Okay, so j sine, then this is going to be 8 phi t plus 2 phi, but 2 phi and 8 phi is going to be same thing because the shift is same, so we can just write it as cos 8 phi t plus j sine 8 phi t. So this is going to be the Euler identity expansion for this exponential form. Now from this one what we have the omega, okay, that is equal to 8 phi. Cos omega t, that's 8 phi. So we can calculate the t using this one. 2 phi divided by omega, that's 8 phi, and that's going to give us 1 over 4. So this is a periodic. So the second one also periodic. Now let's look at the third one. Okay, Let's look at the third one. The third one is s of t is exponential. So s of t is exponential, mean e power negative 7t, then sine 10 phi t. So this exponential is negative, so this is an exponential decaying function. Exponential decaying function. So whenever we have an exponential decaying function multiplied with a sine function, that one become damping oscillation. So if we look this one through a graph, it's going to look like this. We are going to have a wave that's going like this, and the amplitude decrease each time. So finally we will end up with something like this. So this is not periodic because it's not equal everywhere, right? So this is not periodic. Now let's look at the last one. Okay, the last one is s of t is equal to cos 2t cos 4t. Here we can do one thing. We are looking at the d. S of t is equal to cos 2t cos 4t. Here there's an identity says when we have cos 2a, like 2 cos a cos b, that can be expanded as cos a plus b plus cos a minus b. Okay, so we can do the same thing for this one if we have a 2 in front of it. So to get the 2, what we can do, we can multiply and divide it by 2. In that way we will have half times cos a plus b, that's going to be 4 plus 2, that's going to be 6. So cos 6t. A minus b is going to be what? 4 minus 2, that's going to be 2. So cos 2t. This is what we are having right now. From this one we can compare the period. T is equal to 2 pi over omega for the first one. If you look at this one, T1 is equal to 2 pi divided by, what is our omega? Omega is 6, right? So 2 pi divided by 6, that's equal to 5 over 3. And for the second one, let's call this one T2, that's going to be 2 pi divided by 2, that's equal to 5. So we have T1 and T2, so T1 divided by T2 is going to be what? 5 divided by 3 divided by 5, and that's going to give us 1 over 3. And this is a rational number. So this is also a periodic signal. So from this one we can say A, B, D are periodic. And that's going to be the final answer for this question. I hope this helps. Thanks for watching.